Okay, having a look here at this, how we describe the shape of data distributions using skewed, symmetrical or bimodal. First one up here in the top left looks at symmetry. Now this is a set of data that's been graphed, okay, and we can clearly see that from the centre out to the left and to the right, the data mirrors itself, okay, so that's where we have a clear centre, all right, which is where our mean and our median and our mode fit, and then our data trails out to the left or right as a mirror image. So that one there is symmetry. Second one here down the bottom, we've got two graphs. Let's split this up into two, talking about skewed distribution of data. The one on the left here is a negatively skewed set of data, which is where we've got a really long tail over towards that zero value heading towards the negatives over here. We then come up to a bit of a peak here, but most of our data, okay, is skewed off in a negative direction, so it's negatively skewed. What will happen here is the mean will be affected by a set of data like this, in that it won't be in the centre like the median, mean and mode was here, and also the mode might shift a little bit as well. On the right hand side we've got a positively skewed set of data, and you can see the tail over here comes out into a positive direction, so that's how we remember that it's positively skewed. Again, the mean will be affected by a set of data like this one here. Third one looks at a bimodal distribution of data. It's neither symmetrical nor skewed, and what we can see is we've got two peaks which come across here to that same level, and this can generally indicate that there's two sets of data or two groups of people asked the same sort of data, but essentially we've got two peaks within that set of data in that distribution. Okay, now we're just going to have a little bit more of a focus on skewed sets of data. So up here I've just got a quick little diagram looking at a negatively skewed distribution, and down the bottom a positively skewed distribution of that tail coming right out to those larger, more positive numbers. Over the right hand side I've posed you a couple of questions just to focus in on a little bit more. First one is what will happen to the median in data sets like this where we do have a skewness, and the second one is what will happen to the mean, so that's the average score when we have a negative or positively skewed set of data. Hit pause on your video. I want you to try and figure that out for yourself, and then hit play again. We'll come back and talk a little more. All right, you've had a bit of time to think about it now. Coming back to that first one, with our median, the median won't be affected. The middle value is still going to always be the middle value. So a skewed set of data, either way, negative or positive, is not going to change the median. Okay, it's always going to be in the middle. Number two, about the mean will definitely be affected. Okay, it'll move in the direction where most of our data is. So if we look at this one here, most of our data in terms of the frequency hangs over to the right hand side here. So therefore our mean will increase. Okay, if we have a positively skewed distribution of data, most of our values fall in here. The frequency trails off as we head out this way here. So therefore our mean will be decreased, okay, as we more positively skew a set of data.